All right, welcome back to the. All right, welcome back to our video. We're going to be covering 8.1, which is called Go the Distance, and it's going to be developing understanding. Here today you'll be able to find the distance between 2 points in the coordinate plane and find the perimeter of a geometric figure in the coordinate plane. And how can I find the distance between 2 points if they're not vertical or horizontal lines? So here's some context. The performance of the Crawford High School drill team are very popular during halftime at the school's football and basketball games. When the Crawford High School drill team choreographs the dance moves that they will do on the football field, they lay out their positions on a grid like the one shown. What? They use math. In one of their dances, they plan to make a pattern holding long, wide ribbons that will span from one dancer in the middle to 6 other dancers on the grid. Their pattern looks like this. The question the dancers have is how long to make the ribbons. Gabriella G is standing in the center, and some of the dancers think that the ribbon from Gabriella to Courtney will be shorter than the one from Gabriella to Brittany. How long does each ribbon need to be? Okay. So first of all, how long is each one going to be? That's the question that we're going to go after. Okay. Hold on. Okay, I'm back. And maybe you remember how to do this from 8th grade. And one of the things that you learned from 8th grade was the Pythagorean Theorem. The Pythagorean Theorem, as a reminder, says when you have a right triangle, you get leg squared plus leg squared equals hypotenuse squared. Now, I know that some of you have memorized a squared plus b squared equals c squared, but in my years of teaching, I've recognized that there are a bunch of, not equals, it needs to say equals, Ms. Johnson, that not everyone, some students who don't really understand this theorem tend to put whichever side is missing as the hypotenuse, and that's not correct. Only the hypotenuse gets to sit in the hypotenuse spot. So how long does each ribbon need to be? Well, for this one, it looks like from G to C, that's just 5 units long. So that's going to be true for FG and GC. So I'm going to write that. So FG equals to GC equals to 5. The next one that we're going to do is we're going to try to figure out GB. And GB is, I'm going to draw this triangle for you. Do you guys all see this triangle here? So here is my right triangle. And my right triangle has, and then I'm going to redraw him here so you guys can all see him. I sometimes do this so that it's very clear. This is length 4. This is length 4. And we need to learn this side. So go ahead and use the Pythagorean Theorem in order to find the length of this third side. Okay, find the length of this third side. Okay, so now that you're back, you probably did leg squared plus leg squared equals, I don't know, squared. And you got 16 plus 16 equals to question mark squared, which then means that we have to solve this. So this is 32 equals question mark squared. And then you probably remember, I don't know if you remember how to do square roots, but the way the square root goes is you can either use your calculator. I'm going to show you on a calculator real quick. So we need to know what the square root of 32 is. So square root of 32 is 5.7. So it's about 5.7. This is 5.7. So the friend that said that it was going to be longer is correct. So that would take care of GB, GA, GE, and GD. Give me one second. Okay, so let me just write that down. We've got GB, this is going to move out all over. So GB equals to GE equals to GD which is equal to GA, which is about 5.7. Okay. Okay. So this next little part says, explain how you found the lengths of each ribbon. And so you probably say, I use the Pythagorean theorem or what have you. So then it says, when they finish with the ribbons in this position, they're considering using them to form a new pattern like this. Will the ribbons they use in the previous pattern be long enough to go between Brittany and Courtney? Brittany and Courtney is this section here. Is that going to be long enough? Okay, and then explain your answer. So whenever they're asking me for distance, I'm always going to use the Pythagorean theorem. So I'm going to go like this here and drop it down. Oops, I don't know how to draw a straight line, but there it is. There. And so if you look, how long is each side of this right triangle? Okay, and maybe someone said, oh, this is 2, Miss Johnson, and this is 4. So then I'm just going to use 2 squared plus 4 squared equals hypotenuse squared, which equals to 4 plus 16, which is 20. And then I'm going to use square root. And then I'm going to find this on my calculator, the square root of 20. So 4.5. It's about 4.5. So this is, so BC is about 4.5. Okay. And so are the ribbons going to be long enough? And the answer is yes, because so far in the other ones, it was 5 and 5.7. So if they're using them from here to here, then they would work. Okay. So then Gabriella noticed that the calculation she is making for the lengths of ribbons remind her of math class. Yay! She says to her group, hey, I wonder if there's a process that we can use, like what we've been doing to find the distance between any 2 points on the grid. And she just decides to think about it like this. Right? And then she says, I'm going to start with 2 points and draw the line between them that represents the distance that I'm looking for. Since these 2 points could be anywhere, I name them A, which is x1, y1, and B, which is x2, y2. Okay. When I figured the length of the ribbons, what should I do next? Now, I want you to think about the past 2 examples that you did, especially this last one, and figure out, okay, well, first, Ms. Johnson, you told us to find that right triangle, so we're going to draw that in. But then you need to find how long each side is. Now, some of you are going to be tricked by this grid, and you're going to start counting 1, 2, 3. No, I don't want you to count. So if you look at this last one, how can I prove that the length of this is actually 2? That the length of this bottom leg is actually 2 right here. And so then you would say, oh, Miss Johnson, maybe it's because you can just count 1, 2. Yes, but is there another way that we could possibly figure this out? Using the points that they gave us. And you're like, yeah, Miss Johnson, because that 3 is 2 away from 5. Very good. So it's 5 minus 3. So very good. So I would subtract the x's. So the distance here is going to be x2 minus x1. Similarly, your y's are going to be found the same way. So y2 minus y1. And then now we can kind of use the Pythagorean theorem in the same way, right? So it says, think back to a process from the ribbon. Okay, we just did that. Use the process you came up with in problem 4 to find the distance between away from each other from your problem using -11 and 12. Okay, so the last thing that we're going to do here is we're going to actually use the Pythagorean theorem on this. So this is my hypotenuse. So then you would say, well, what I did, Miss Johnson, is I took x2 minus x1, and then I squared it, because that's what we did. It's like squared. And then I added it to the other leg, and I squared it. And that's equal to the hypotenuse squared. Very good. And then if you look at that last step that we did, we square rooted it. So here, I'm just going to take this and square root this and this. And over here, the hypotenuse squared and the square root would undo each other. So this is actually the formula that we would use to find the distance between any 2 points. Okay, so you're going to use this formula over and over again. If you don't remember it, it is okay to use the Pythagorean theorem. And so let me show you both ways and you can figure out which way you like better. So I'm going to graph both of these kind of like in the air, not on a grid, rather. It says 23 comma negative 16. So 23 comma negative 16 probably looks somewhere right here. 23 comma negative 16. And the other point is negative 11 up 25, which probably looks right here. Negative 11 comma 25. And so what I want to do is I want to find the distance between these two. And then the way I do that is I'd find the vertical and the horizontal distance that way, and then I'm pretty much done. So how far is this part from this part? And you're like, well, this is 23, Miss Johnson, and this is negative 11. Good. How far are they? And you're like, 23 minus negative 11 is 34. And then you would do similar over here. And you would go, how far is 25 from negative 16? And you're like, oh, that's 41. So then I'm going to use 34 squared plus 41 squared, and then I'm going to square root it, and that's the distance. And I'm going to plug all of this into my calculator because I don't want to make a mistake. So 34 squared plus 41 squared, and it's about 53.3. Okay. And that's pretty much all we have to do. And then the rest of this will be explained during class. So thanks so much for listening. Have a great day. Bye.